Hello, everyone. And welcome back once again in another video. If you're preparing for a JavaScript interview or just looking to level up your JavaScript skills, you're in the right place. In today's video, we'll discuss top JavaScript interview questions, providing clear and concise answers to help you ace that interview or strengthen your coding knowledge. If you're ready, let's start today's video. Question 1. What is JavaScript? JavaScript is a high-level, interpreted scripting language primarily used for web development. It enables developers to add interactivity, manipulate the document object model or DOM, and create dynamic web applications. JavaScript is a versatile language that runs in web browsers and can also be used on server-side platforms like Node.js. It supports both procedural and object-oriented programming paradigms and is known for its ability to handle asynchronous operations effectively. JavaScript plays a crucial role in modern web development, allowing for the creation of interactive user interfaces, form validation, and much more. Question 2. Explain the difference between null and undefined in JavaScript. In JavaScript, null and undefined are both values representing the absence of meaningful data, but they are used in slightly different contexts. Null is explicitly assigned to a variable or object to indicate the intentional absence of a value. It is a deliberate action by a programmer to signify that there is no value or object at that location. On the other hand, undefined indicates that a variable has been declared but has not been assigned a value. It typically occurs when a variable is declared but hasn't been initialized with any data. JavaScript automatically assigns undefined to variables that are declared but not explicitly assigned a value. This subtle difference is important when writing code to handle these cases effectively. Question 3. What are the data types in JavaScript? JavaScript has 7 fundamental data types: undefined, null, Boolean, number, string, symbol, and object. Each data type serves a specific purpose. Undefined. It represents an uninitialized or undeclared variable. Null. It represents the intentional absence of any object value. Boolean. It represents true or false values. Number. It represents numeric values, including integers and floating point numbers. String. It represents text and characters. Symbol. It introduced in ECMAScript 6, ES6, symbols are unique and immutable values used as object property keys. Object. It represents a collection of key-value pairs, where keys are strings, or symbols, and values can be of any data type. Objects are the most complex data type in JavaScript and are used to represent structured data. Question 4. How do you declare variables in JavaScript, and what's the difference between var, let, and const? In JavaScript, variables can be declared using var, let, or constant. The choice between them affects the scope and mutability of the variable. Var. Variables declared with var have function-level scope. They are hoisted to the top of their containing function or global scope, which can sometimes lead to unexpected behavior. Var variables can be redeclared within the same scope. Let. Introduced in ES6, let variables have block-level scope, making them more predictable than var. They are also hoisted but are not initialized until the declaration statement is executed. Unlike var, let variables cannot be redeclared in the same scope. Const. Const variables are also block-scoped and cannot be reassigned once a value is assigned to them. They must be initialized at the time of declaration, and attempts to change their value will result in an error. Choosing the appropriate declaration keyword depends on the desired scope and mutability of the variable in your code. Question 5. Explain hoisting in JavaScript. Hoisting is a JavaScript behavior that involves moving variable and function declarations to the top of their containing scope during compilation. This means that even if you declare variables or functions later in your code, they are effectively hoisted to the top of their respective scope during the execution phase. However, it's important to note that only the declarations themselves are hoisted, not their initializations. For example, if you have written code like this in JavaScript, JavaScript will interpret it as showing on the screen. This behavior can sometimes lead to unexpected results if not understood properly, so it's essential to declare variables and functions at the beginning of their scope to maintain code clarity and predictability. Question 6. What is a closure in JavaScript, and why is it useful? A closure is a fundamental concept in JavaScript, and it occurs when a function closes over its lexical scope, preserving access to variables and parameters even after the outer function has finished executing. In simpler terms, a closure is a function that retains access to variables from its parent scope, even if that parent function has already completed. Closures are useful for several reasons. 1. Data encapsulation. Closures allow you to encapsulate data, providing a way to create private variables and functions. This helps maintain data integrity and security. 2. Function factories. You can use closures to create functions with specific configurations or behaviors. This is often seen in libraries and design patterns. 3. Callbacks and event handling. Closures are frequently used when defining callbacks or event handlers. They allow the callback function to access variables from the outer scope, which is crucial for maintaining state in asynchronous operations. 4. Memory efficiency. Closures can help optimize memory usage by allowing variables to be retained only as long as they are needed. Understanding closures is essential for advanced JavaScript programming and is often tested in interviews to assess a developer's knowledge of JavaScript fundamentals. Question 7. How do you handle asynchronous operations in JavaScript? JavaScript is single-threaded, meaning it can only execute one operation at a time. However, many tasks in web development are asynchronous, such as fetching data from a server, reading a file, or responding to user interactions. To handle asynchronous operations effectively, JavaScript provides several mechanisms. 1. Callbacks. Callback functions are a common way to handle asynchronous code. You pass a function as an argument to another function, and it gets called when the asynchronous operation completes. 2. Promises. Promises were introduced in ES6 and provide a more structured way to work with asynchronous code. They represent a value that may not be available yet but will be at some point in the future. Promises can be in one of three states: pending, fulfilled, or rejected, and you can attach then and catch handlers to handle the result or error when the promise settles. 3. Async await. The async and await keywords, also introduced in ES6, provide a more readable and concise way to work with promises. An async function returns a promise, and you can use the await keyword inside the function to pause execution until the promise is resolved or rejected, making your code appear more synchronous. 4. Event listeners. For handling events such as user interactions, example, button clicks, mouse movements, you can attach event listeners to elements in the DOM to execute code asynchronously in response to these events. 5. Timers. JavaScript allows you to schedule code to run after a certain delay using functions like setTimeout and setInterval. The choice of which method to use depends on the specific use case and the level of control and readability you need in your code. Question 8. What is the event loop in JavaScript? The event loop is a core concept in JavaScript that enables asynchronous operations to be handled in a non-blocking way. It's the mechanism that allows JavaScript to perform tasks such as responding to user input, fetching data from a server, or handling timers without freezing the entire program. Here's how the event loop works. 1. JavaScript maintains a call stack, which keeps track of function calls and their execution contexts. 2. When a function is called, it's added to the call stack. If the function makes an asynchronous request, example, fetching data from a server or setting a timer, that request is handed off to the browser's web APIs, in the case of a browser environment. 3. The event loop continuously checks the call stack and the message queue for pending tasks. 4. When the call stack is empty, meaning all synchronous code has been executed, the event loop picks the next task from the message queue and pushes it onto the call stack for execution. 5. This process repeats, allowing asynchronous tasks to be processed in the order they were completed, while still allowing the program to remain responsive and non-blocking. The event loop ensures that JavaScript can handle asynchronous operations efficiently, making it suitable for building responsive web applications. Question 9. Explain the concept of callback functions. Callback functions are functions that are passed as arguments to other functions and are executed after the completion of the parent function. They are a fundamental concept in JavaScript and are used extensively in asynchronous programming. Here's a simple example of a callback function. In this example, the greet function takes two arguments, name and callback. It logs a greeting and then calls the callback function. In this case, the sayGoodbye function is passed as the callback and is executed after the greeting. Callback functions are commonly used in scenarios like handling asynchronous operations, event handling, and more. They allow you to specify what should happen once a particular task is completed, making your code flexible and responsive. Question 10. How do you manipulate the document object model or DOM using JavaScript? The Document Object Model or DOM is a programming interface for web documents. It represents the structure of a web page as a tree-like structure of nodes, where each node represents part of the page, such as elements, attributes, and text. JavaScript allows you to interact with and manipulate the DOM to create dynamic and interactive web applications. Here are some common ways to manipulate the DOM using JavaScript. 1. Selecting elements. You can select elements by their tag name, class name, ID, or other attributes using methods like getElementById, querySelector, getElementsByClassName, and more. 2. Modifying elements. You can change the content, attributes, and style of elements using properties and methods like innerHTML, text content, setAttribute, and style. 3. Creating and appending elements. You can create new elements with document.createElement and append them to the DOM using methods like appendChild or insertBefore. 4. Removing elements. You can remove elements from the DOM using the removeChild method. 5. Handling events. You can attach event listeners to elements to respond to user interactions like clicks, mouse movements, and keyboard inputs. 6. Manipulating CSS. You can change the CSS properties of elements to control their appearance and layout. 7. Traversal. You can navigate and manipulate the DOM tree by moving between parent, child, and sibling nodes. By manipulating the DOM, you can dynamically update the content and behavior of web pages, making them more interactive and responsive to user actions. Question 11. What is the purpose of the this keyword in JavaScript? In JavaScript, the this keyword refers to the current execution context, and its value can vary depending on how and where it is used. Understanding the context of this is essential for working with objects, functions, and constructors effectively. Here are some common scenarios. 1. Global context. In the global context or outside of any function or object, this refers to the global object, which is window in web browsers and global in Node.js. 2. Function context. Inside a function, the value of this depends on how the function is called. In a regular function, this refers to the global object, example window, in non-strict mode, or it is undefined in strict mode. In a method, a function defined inside an object, this refers to the object itself. 3. Constructor context. When a function is used as a constructor to create objects, example, with a new keyword, this refers to the newly created object. 4. Event handlers. In event handler functions, this typically refers to the DOM element that triggered the event. 5. Arrow functions. Arrow functions do not have their own this binding but inherit the this value from the surrounding lexical, enclosing, context. Understanding the context of this is crucial for writing object-oriented JavaScript and for managing the scope and behavior of functions and methods. Question 12. How can you handle errors in JavaScript? Error handling is an essential aspect of writing robust JavaScript code. JavaScript provides several mechanisms for handling errors and exceptions. 1. Try-catch statement. The try block allows you to enclose code that might throw an exception. If an exception occurs, it can be caught and handled in the catch block. This prevents the entire program from crashing due to errors. This is the syntax of try-catch statement in JavaScript. 2. Throw statement. You can use the throw statement to manually throw custom exceptions or errors when specific conditions are met. This is the syntax of throw statement in JavaScript. 3. Error object. JavaScript provides a built-in error object and various derived error types like syntax error, reference error, and type error. These objects provide additional information about the error, including a message and a stack trace. This is the example of error object in JavaScript. 4. Finally block. You can use the finally block after a try-catch statement to specify code that should always be executed, whether an exception is thrown or not. This is the syntax to handle error using finally block in JavaScript. 5. Global error handling. You can set up global error handlers using window.onError in the browser, or the process.on, unCaughtException, event, in node.js, to catch unhandled exceptions at the application level. Handling errors gracefully is essential for improving the reliability and user experience of your JavaScript applications. Question 13. What is a callback hell, and how can you avoid it? Callback hell, also known as the pyramid of doom, is a situation in asynchronous JavaScript programming where multiple nested callback functions become challenging to read and maintain. It occurs when you have a series of asynchronous operations that depend on the results of previous operations. As you add more nested callbacks, the code indentation deepens, making it harder to understand and prone to errors. Here's an example of callback hell. To avoid callback hell and write more readable asynchronous code, you can use the following techniques. 1. Named functions. Define your callback functions separately and give them meaningful names. Then, pass these named functions as callbacks, improving code readability. This is the example of how you can use named functions in JavaScript. 2. Promises. Promises provide a more structured way to handle asynchronous operations. They allow you to chain asynchronous tasks together using then and catch methods, reducing the need for deeply nested callbacks. This is the example of how you can use promises in JavaScript. 3. Async await. With the async await syntax, you can write asynchronous code in a more synchronous-looking style, improving readability. This is the example of async await in JavaScript. These techniques help make your code more maintainable and easier to understand, even when dealing with complex asynchronous operations. Question 14. What are arrow functions in JavaScript, and how are they different from regular functions? Arrow functions are a concise way to write functions in JavaScript, introduced in ES6, ECMAScript 2015. They provide a more compact syntax compared to regular functions and have some differences in behavior. This is the syntax of regular function and arrow function in JavaScript. Regular functions have their own this context, which can change depending on how the function is called. The value of this is determined at runtime. Arrow functions do not have their own this binding, they inherit the this value from their enclosing or lexical context. This means that the value of this inside an arrow function is determined by the surrounding code and is fixed when the function is created. Regular functions have an arguments object that represents the arguments passed to the function. Arrow functions do not have their own arguments object, instead, they inherit the arguments from their enclosing function. Use cases. Arrow functions are well suited for concise, one-line functions and for functions that need to preserve the surrounding this context. They are commonly used in modern JavaScript code, especially for callbacks and inline functions. Conclusion and recap for this tutorial. That's a wrap for today's video on the top JavaScript interview questions and answers. We've covered the fundamentals, data types, variable declarations, hoisting, closures, and handling asynchronous operations. If you found this video helpful, don't forget to hit that like button, subscribe to this channel for more tech content, and let me know in the comments if you'd like to see more videos like this or have any questions. Thanks for tuning in, and I'll see you in the next video. Happy coding!